Hi, Emily.
Hi. I'll have to bring my computer and see what's going on. Maybe you can see because the camera doesn't seem to work at all.
Okay.
But I don't know what you think I'm lying or something. Because I would turn it on if it would work.
Oh, you are just so deceptive. I never can trust you. All right. So, Emily, were you able to go back and rewatch the video that you missed?
Yes, ma'am.
The actual live lesson?
Yes.
Right. Did that make sense as you were working through the practice problems 11, 13, 14, 15?
Yes, but for 15 I didn't understand so well, but I got 13 and 14.
Okay. So, and did I give you the answers so you could check your work or not?
I do have the answers in the book.
Oh, yeah, that's right, because you have a book with the answers.
Yeah.
Okay, so you were able to go through the problems, and then you were able to check your answers, and
Yes.
13, 14, you got fine.
Yes.
Great. So what we'll do is start with 15 then. So I'm going to type in a flowchart that I really think is very helpful as you're thinking through conversions, okay?
Mm-hmm.
Grams of A. There. All right, so you can turn grams of A into moles of A by doing a mole grams to mole conversion, right? We use the molar mass to do that. That's all the things that we learned in chapter 10.
Mm-hmm.
You can turn moles of A into moles of B by using the mole ratio that we just learned how to do. And remember that you use the coefficients from the balanced chemical equation to do that mole ratio.
Okay.
And then you can turn moles of B into grams of B by doing, again, the molar mass and using that conversion to go from moles to grams. So you're going to use your periodic table for that. But does that make sense how this flow chart works? You can do, you can't do grams directly of grams of A to grams of B, right?
Mm-hmm.
But you can step by step change things and take it to grams of B.
Okay.
So that's kind of the process we're going to work through is working through this. And this is, notice how each arrow, that's kind of like a section in your conversion table.
Mm-hmm.
Right? So whenever you see an arrow, you're going to think, oh, I need a new section to convert this into that.
Okay.
So when you do a gram to gram conversion, there's really how many steps?
Like 4.
Count the arrows.
Oh, there's 3.
There's 3. So we're going to have 3 separate steps on this conversion table, okay? So essentially 3 separate sections with a top and a bottom, okay? Mm-hmm. And that's really the basic idea of this. Now, this flowchart actually works no matter where you start or where you stop. If we were starting with just grams of A and turning it into moles of A, we'd only do 1 conversion. If we start with moles of A and go to moles of B, there's only 1 conversion, right? So you can start anywhere and end anywhere. So it actually does spell out all of these problems quite nicely. All right, so now what we're going to do is start here. It says on number 15, 2NaN3 solid yields 2Na solid plus 3N2 gas. Mm-hmm. Notice that they give you, Geiger, leave it alone. They give you how many grams of NaN3 in the pitcher?
NaN3 in the pitcher.
Yes. So notice to the right how there's a diagram of a
They have 3.
the steering wheel with the bag deployed. All right. Underneath that picture, you see they give you the number of grams that you start with.
Okay. 100.0.
Good. So what we're going to do is start our table with that.
Okay.
And what do they want in the end? What are they asking for?
Let me determine the mass of N2 produced by the decomposition of NaN3.
Good. So notice you're looking for mass. What's the unit what unit do we associate with mass?
Grams.
Good. So we're looking for grams of N2. So notice how I've got the big long table set up and I've got over here my reminder. When I get to grams of N2, I'm going to stop.
Okay.
All right. So now just talk me through. Are you allowed to turn NaN3 directly into N2?
No. Let's do that.
Good. How do you turn NaN3 into N2? What unit do you need to be able to do that change?
I don't know.
All right. To get from one thing to another thing, remember how we have a bridge that we build? So let me write out my equation. Okay, so here's our equation, right?
Mm-hmm.
And in order to change one thing, so we're starting here at NaN3, and we're looking for N2 all the way over here, right?
Okay.
We have to literally cross this. It's almost like we're crossing a river. We're going to make a bridge, and this bridge is going to always be our mole ratio, right?
Mm-hmm.
So in order to get from this thing into that thing, you must have moles.
Okay.
Do we have moles?
Not in that. No.
We don't. Good. So the very first step you have to do is turn grams of NaN3 into moles of NaN3.
All right, so we put moles on top and grams on bottom.
Good. All right. Now,
how do we know how many moles to put on top?
This is actually chapter 10, and you've already done it when you did your last couple problems with 13 and 14. When we're going from grams to moles, it's always how many moles?
Just one.
Always just one, every single time. Grams to moles, 1 mole. Okay?
Mm-hmm.
Now, how do we figure out the mass for NaN3?
Do we have to find the mass of NaN3 on the periodic table?
Yes. Good. So go ahead and use your periodic table.
Okay. Na is 22.99 and N is 14.00. So we have to add those together, I'm assuming?
Hang on, let me make sure on 14.0. I think that 14.01, because you're going to round up because there's a 7 afterwards.
Oh, okay.
And let me see the NA, because you might... Yeah, you were right. Okay, so now, remember that when I'm finding molar mass, I'm going to write out my elements. I have Na, and then I have N, and I'm going to write out their coefficients.
Mm-hmm.
How many Na do I have?
All together?
Yes, sodium.
Oh, a lot. 3? No, 2.
Na. Hang on. NaN3. See? How many of those are sodium?
I see 2. I'm confused. I see 1 in brackets, NaN3, and the next one right next to it has a 2 coefficient, and then the NaN3.
Oh, you're actually looking... Okay, so the problem is written funny on the book. Don't look at the thing in brackets before. Notice how that has a, it almost looks like a frown face because it's got the colon after the brackets.
Yeah.
Yeah, that was like extra information.
Oh, okay.
Anything to that side, don't look at. So you're only looking at the equation, which is starting with
Just one then.
2NaN3. Good. So you just have one of them. So look, we're going to go 1 times 22.9. How many of your n's do you have?
Just one.
Nope. Look at your subscripts.
2. 3. You have 5 altogether.
1, 2, 3. I don't know. All right. So here's how you find that out. Look at your subscripts. Sodium is Na. You have one of them because you don't have a subscript. If you don't have any subscript written, you know it's a 1. Nitrogen right here. How many of them do we have?
3.
3. So notice, look, when you're finding the molar mass, you multiply the number of them that you have by its mass.
Okay.
So we have 3 of them times 14.01. All right, so obviously the top one is going to be 22.99 because it's times 1. But let's take our calculator and type in 3 times 14.01.
4203.
Yep. So now we're going to take and do what with these two numbers?
Can I add them together?
Yes.
$65.02.
Good. Now that is the mass that NaN3 has. It's actually written out as grams per mole. Now that's why we can plug it in here. That number of grams for 1 mole. So we have 65.02 grams of NaN3 on the bottom and 1 mole of NaN3 on the top. That's your first conversion.
Okay.
Now, check this out. Ready? Here we go from grams to moles, right? But we still have NaN3.
Yeah.
Right? So the grams is what's canceling. See how grams is on the top and the bottom?
Yeah.
So that's gone now. Now what we want to try to do is change moles of NaN3 into moles of what we want, which is what?
You're going to grams again?
Um,
I'm confused. So we're going from moles to grams? Is that what you're asking?
Nope. Ready? How do we get from this thing to this thing?
We have to cross the bridge.
Cross the bridge. What is this bridge? The what bridge?
Mole ratio.
Mole ratios. We need to put a mole ratio here. Do we have moles now?
Yeah, 1 mole.
So we can do mole ratio. Because we have moles, now we can use a mole ratio, see? Okay, so look. Whatever you have up, notice how this is the same thing. We had grams of NaN3. Immediately went down here to cancel, right?
Yeah.
Whatever you have up here immediately goes down here to cancel. We have moles of NaN3. It needs to go down here to cancel.
So you just put another 1 mole of NaN3?
Don't put any numbers yet. Just put moles. NaN3. We'll talk about the numbers in a second.
Okay.
So just leave it blank with no number, but just put mole NaN3 on the bottom. I have to respond to this really quick. What's going to go on the top? Moles of what thing? What are you looking for?
Moles of what thing?
What thing are you trying to change this into? What are you looking for?
N2. N2.
So you put moles of N2 on the top. Hang on. There. All right. Just had to send that because if I don't respond to a text when I see it, I will forget that I got it, and the sensor's no longer a number 1 by my messages.
Oh, I see.
I totally forget to respond, and then I end up like going an entire week and somebody thinks I hate them because I never responded.
I get that, yeah.
So just had to answer them. So notice how we have moles of NaN3 turning into moles of N2, right? Now, where do we get the numbers for the mole ratio? We've talked about this already. From the what?
The coefficient, so is it 3 on top and 2 on the bottom?
That's perfect. Good.
And we get our mass from N2, which is 28.02. We put that on the bottom?
Close.
Okay.
Now, really quick, let's just see how things cancel. So notice that now moles of NaN3 is on the top, moles of NaN3 are on the bottom, right? So that's going to cancel. Now, what has to go down here to cancel?
Moles of N2.
Good. So that it'll cancel. Because what do we want in the end? Not moles, but
Grams.
grams. So what's going to go on the top?
Grams.
Good. Now, what numbers go in the grams and the moles for this?
The grams would be, the moles would be 2, right? Or
maybe. I'm not going to answer yes or no yet. What goes with the grams?
oh, with the grams, 28.02.
Good. Now that is correct. Now look, when we go grams to moles or moles to grams, it's always how many moles?
Just 1.
Always. Always just 1. Okay? Here's why. Do you see this unit right here that we found already? Grams per mole? This is what bases 1 mole and the number of grams. This is what that's based on. It's because it's the unit of grams per mole. If I were to say you're driving down the road and you're driving a speed of 65, I'd say 65 what to convey my meaning?
Oh, is that a question?
Yes. 65 what? 65 what?
Miles per hour?
Yes. But that means, like, if I have this, I'd write it out as miles per hour, right? Miles over hour. I could rewrite this as 65 miles over how many hours?
1 hour, 1 mile per hour.
1 hour. In 1 hour, you drive 65 miles, right? Right. It's the point is that when it's per, when you're dividing like that and you say per, it's always over 1 of the other thing.
Okay.
Okay, so that's when we say miles per hour, we always mean in 1 hour. If we're doing 25 miles per hour, if we drove 1 hour, we would have gone 25 miles.
Yeah.
Right? That's why when we say this is the molar mass, and the molar mass is measured in grams per mole, that's why it was 65.02 grams, and you put 1 mole on the top. And that's why on the other side, when you did moles to grams, you put 1 mole on the bottom and 28.02 grams on the top, because it's grams per mole.
Okay.
And it's always 1. Does that help with that?
Yeah.
All right, so now what happened with my unit here? Moles of N2, what did they do?
They cancel out.
Good, and what are we left with?
We're left with grams.
Good. So what do we do now that we have it all set up nice and pretty?
We have to divide and multiply. Multiply and divide.
Multiply and divide. So look, you can do this one of 2 ways, and I'm going to teach you both. So start with your calculator, turn it on. All right, ready? Yeah. We're going to start and we're going to do all of the multiplication first.
Okay.
Straight across. Anything that needs to be multiplied, we're going to type it in. So we're going to go 100. Sorry. And we're going to go, what's the first thing we have to multiply by?
1.
Times 1, which is the same thing. So I'm going to skip it.
Okay.
Because times 1 is itself.
Yeah.
What's the next thing?
3.
So times 3 equals?
300.
Hang on. Oh, I pushed times twice. Sorry. Times 3. Yes, equals 300. Now, what's next?
28.02.
Times 28.02 equals. 8,406, right? Now we're going to go through and do all of the division. All right, so we're going to start with divided by what?
Oh, wait. 65.02.
65.02 equals, okay? Then divided by what?
2.
Good. And your final answer will be?
0.0646.
You have typed something in wrong.
All right, so I'm going to put 8.46.
I wish I could see your screen. It makes it so much easier. All right,
Sorry.
so here's what I need to do again. Ready? Clear your screen.
Okay.
Type it in exactly as we were saying. Ready? Go 100 times 3. Push enter. All right. And you tell me as you do these, you just tell me what you see.
Okay, so I got 300.
Now push multiply again so it has answer.
Okay. 28.02 equals
Equal.
84.06.
Good. Now push divide.
Okay.
65.02.
Okay, equals, I get 129.28.
Good. And then you have to divide it again by
2.
good. And then push equals. What do you get?
Okay, 64.64.
Good. And then with 4 sig figs, that's just 64.64.
Okay.
All right. Emily, the other way to do this. Some people don't like doing all of that. And so what they try to do is they do all of the multiplication here, and then they multiply everything on the bottom, and then they just divide those numbers. So what they would have done is they go 100 times 3 times 28.02. And they get 8,406.
Okay.
Over, and then they multiply everything on the bottom so that they know what to divide by. And they only divide once, okay? So they go 65.02 times 2. See how that's the two things on the bottom? So they're going to divide 8,406 by 130.04.
Okay.
And so they are going to end up with the same answer. It's just sometimes some people don't like typing it out separately.
Yeah.
Okay, so I don't care which method you use. I prefer to do the one where I just type it in my calculator, and I don't prefer this method as much.
Yeah, I don't like that one.
Okay, all right, so we'll go with the method that we're used to. The other thing I'd like to point out really quick, remember how we did our flow chart? Grams of A to moles of A, moles of A to moles of B, moles of B to grams of B, right? Look at your chart and look, see how we did that. This is grams of A. It's the first thing we start with, right?
Yeah.
Doesn't matter what this is, it's the first thing we start with. That's A. So notice how we turned grams to moles, but it's still A. Right? Now, that was our first arrow, this conversion. Notice the next arrow. We're going to change from moles of A
to moles of B.
To moles of B. See how you changed this into that? But it's still moles, right?
Yeah.
And then the last arrow was this conversion. Grams of B, or I'm sorry, moles of B into grams of B.
Yeah.
See how the N2 is still the same? But you changed moles to grams? That's this flow chart, okay?
Okay.
Does that make more sense?
A little bit more, yeah.
Okay, so notice how there were 3 conversions. 1, 2, 3. Good?
Yeah.
All right, and the other thing I really want to stress right now, if we call grams and moles and like atoms and molecules, those are all like our unit. The other thing is just the actual thing we're dealing with, whatever the chemical or molecule or whatever it is, okay? You cannot change the unit and the thing you are dealing with at the same time. You can only change one of them. So notice how in here, the first step, we kept the thing, the NaN3 stayed the same.
Yeah.
But the unit changed. See?
Yeah.
Here, what changed?
The number, no, the unit.
Did the unit change? Look, what do we have on top and bottom here?
We both have moles, but
Good.
the N2 and whatever that's called.
Yeah, that's the thing that we're dealing with.
Okay.
The unit stayed the same. The thing that we're dealing with changed, right?
Mm-hmm.
And then here, what changed?
The units.
The units, good. But the thing that we were dealing with stayed the same. You never can change them both in the same step.
Okay.
Only one or the other. James is being funny. Sorry. All right, let's practice another one.
Mm-hmm.
Let's see. The challenge problem says in the formation of acid rain, sulfur dioxide reacts with oxygen and water in the air to form sulfuric acid. Write the balanced chemical equation, and then it gives you conversion. So I'm going to help you out. I'm going to write the balanced chemical equation for you because I don't want you to spend time there as much as I want you to spend time working through the problem. Okay? Mm-hmm. So you're going to start with 2 SO2. I'll write it down and then I'll show you. 2 SO2 gas.
Thank you.
You're welcome. Plus O2 gas. And also, I'm not going to give you ones where it's like 3 different reactants.
Mm-hmm.
Those are, that's when I make you balance, it's not going to be quite that involved.
Okay, that sounds good.
Yeah, I made the mistake of having everybody else start. What was it? Challenge problem number 12 is one where they have like, it's a crazy one to balance. If you remember watching that.
Yeah.
I realized afterwards, I was like, oh, we just wasted so much time and we didn't need to. So that was my bad. All right. Here's your equation. Can you see the whole thing?
Not the first part so much. So I have 2 SO2.
Yep.
Plus O2 grams. Plus 2 H2.
H2O. Yep.
H2O, or is it H2SO4?
Oh, sorry. Are you here?
No, on the last one.
Oh, got it. This is H2SO4. Yeah.
Thank you.
Yep. And by the way, the G's mean gas.
Mm-hmm.
The L means liquid, and the AQ means aqueous.
Mm-hmm.
All right. So the problem gives you 2.50 grams of SO2. 2.50 grams SO2. And they would like you to convert into grams of H2SO4. So go ahead and talk me through how you convert from grams of SO2 into grams of H2SO4.
Okay. So we're going to put the number that they give us, the 2.50 first.
Mm-hmm.
2.50, and that's grams. Yes, grams. Then we need to go to, since we're at grams of A, we need to go to moles of A.
Good.
And by doing so, we're going to put the coefficients, or is that later?
All right, so think through. This is something you know. How do you turn grams into moles?
Okay, 1 mole.
Good, 1 mole. Where? Top or bottom?
On top, so it doesn't cancel out.
Good.
Okay, it would. And then we put grams of the SO4. The SO4? I'm so confused.
SO2. BS.
SO2.
All right, so help me find the molar mass. How many sulfurs do you have?
We have 1.
Good. And how many oxygens do you have?
2.
Good. I already know oxygen is 16.00. Let's look up sulfur. Sulfur would be 32.07.
Okay.
That's 32.
So it's 64.07.
64.07, good.
Okay, and that's grams of SO2.
Mm-hmm. And you turn that into?
And you turn that into grams of.
It looks like this, right?
Uh-huh.
Okay, so look, that's turning grams into moles. That's grams of A into moles of A.
Mm-hmm.
Now, what's next?
Now do we do the coefficients?
Good, because what are we doing?
We are turning the grams into, no, the moles and, I don't know, something.
Moles of A into?
Moles of B.
Good. So we have moles of what on the bottom?
We have moles of something on the bottom.
All right, look through and look, try to start with your canceling and everything, okay? So look, what do we have here? Grams of what?
SO2.
And now it canceled, right?
Mm-hmm.
So what do we have right now? Not grams, but moles of what?
SO2.
And do you want that or do you want to cancel that?
Let me cancel it.
So what has to go on the bottom?
Moles of SO2.
There you go. So you put moles of SO2 on the bottom.
Just 2. And then we're going to have moles of 2H2.
What are you looking for?
What are we looking for? Is it going to be SO3?
What are they asking you for? Look at the problem. They're looking for
SO4.
What?
H2SO4.
Yep, that's it. So how many moles of H2SO4 do we have?
We have 2.
Good. All right, so notice, cross out your moles of SO2. Those have canceled. And now we have moles of what?
SO4. H2SO4.
Good. So what has to go down here?
Moles of H2SO4.
Good.
And then we're going to put the grams on top.
Yep. How many moles?
1.
Always 1. Good. So when we're doing grams to moles, always 1. So now all we have to do is find the mass of H2SO4. So hydrogen, sulfur, and oxygen. How many hydrogen do I have?
2.
Good. How many sulfur?
SO, so just 1.
Good. And then how many oxygens?
4.
Good. So hydrogen was 1.01, sulfur we already know is 32.07, and oxygen is 16.00.
Mm-hmm.
So multiply those and add them together and tell me what you get.
Um, $98.09.
Good. All right, so now what canceled?
The moles did.
Good, the moles canceled, and we're left with grams of H2SO4. Is that what we want?
Yes.
Good. So now what do you do?
Multiply the top and divide by the bottom.
Multiply by the top, divide by the bottom. Good.
Oops. So 3.83.
Good. That's it. All right, Emily. Grams to grams. How do you feel?
Grams to grams? Is that what we just did?
That's what we just did. Grams to grams.
It's an easy process once you get it down.
It is an easy process, but you have to do it a couple times, right? But this is, look, the nice thing about these problems is they're a pattern.
Yeah.
It's always the same.
Mm-hmm.
This setup, it doesn't matter what you're dealing with. If you're going from grams to grams, you're going to have these 3 steps in this order every time. Okay? So that's the nice thing is it's just a pattern. And once you learn how to work with this pattern, it's going to be easy. So do you feel like you can try your 4 problems for homework, or do you feel like you want to work one of those right now?
I wouldn't mind working one.
Okay, so let's go back to the back, to the chapter review.
What page is it on?
Hang on, it's 11.3, correct?
11.3.
This is section 11. No, this is 11.2. Okay, so it's on page 393. And I think I assigned you guys 60 through 63.
Oh, 393.
I'm sorry, 393 is what did I say 393?
You did.
Good, okay.
And then 60 through 63.
60 through 63, yep. Let me find one that's going to be good. Let's start with number 60.
Okay.
All right. So I'm going to have you talk me through it, and I will only intervene if I need to.
Okay.
So first you're going to have to do is balance. So start with that.
Okay, I'm writing it out right now, so.
Yep, I am too, actually, so. All right.
Okay.
So what do you do first when you're balancing?
Put all the letters down, so C-H-O.
Good.
And we have 6 C's on this side, and then 12, and then 6. And we have 2, 3 C's on the other side. Is that a G? What did I put down for that?
How many H did you say?
5 looks like a G. Okay, so we have 6 hydrogens.
Good. There are 6 of them. Good.
3 oxygens.
Good. Okay, so what do you want to try to fix first?
The carbon. So
okay.
We're going to have to go on the other side, I'm assuming.
All right. Here, let me give you a strategy.
Mm-hmm.
Is carbon in more than one spot on the other side?
Yes.
Don't try to solve it first.
Okay.
Because you won't know whether to solve it in the C2H5OH or whether to try to solve it with the CO2.
Mm-hmm.
All right. Is there anything here that's only in one part on the product side?
Hydrogen.
Hydrogen. Okay, so try to fix that one first.
Okay, so if we do it by 2, just assuming, so then we have be 6 for C.
Okay, so try that again with C. Notice that you'd have 2 times 2, which is
2 times
4.
2 times 3. Okay.
Plus, but I know why you did that, because look, what you did is you said, oh, I have 3 of them, 3 times 2. But look, there was 2 from here and 1 from there. So really what you have to do is you have to add them from each spot still.
Mm-hmm.
So when you added the coefficient of 2 here, that's 2 times 2, 4 of them, right?
Yeah.
Plus, how many from this side?
Just 1, so we have 5.
So you have 5 total right now. That will change later, but right now you have 5. And how many oxygen do you have? Same idea. You have to account for the ones from this side, for the C2H5OH and from the CO2.
Mm-hmm. How many oxygen? It'd be 2 times 2, not 2 times 3. It'd be 4.
Yes, you have 4.
So that wouldn't really help us. So what if I did by 3?
Wait, what?
Changing the coefficient?
Oh, look, you have how many oxygen? From here you have 2 times 1, so that's 2, plus 2 from there. So that's going to be 4. So you have a total of 4 right now. Yeah. Now, where are you going to change to fix the carbon and the hydrogen? I'm sorry, the carbon and the oxygen.
On the product side?
You are going to change the product side, but are you going to try to mess with the C2H5OH anymore?
I might have to fix the hydrogen.
All right, maybe, but the hydrogen's already fixed right now, right?
Mm-hmm.
So try not to change that anymore.
Mm-hmm.
Notice that you have carbon and oxygen together, right?
Mm-hmm.
So what we're going to try to do is only change the CO2. on that side,
Okay.
right? So look, do yourself a favor. How many carbon total do you need?
6 to match the other side.
All right, so we're going to set up a little bit of an algebra problem. 6 equals how many from here?
6 equals just
How many carbon is this giving?
2.
2 times 2.
4.
4. 4 plus x. Because we're going to try to find out how many carbons do we need from here. So we don't want to change this, right? This is giving me 4, and I don't want to change it. So we're trying to find out how many more carbons do I need right here. That's how you do that. See?
Just 2 more?
You need 2 more. How do you get that to be 2 carbon?
I don't know, because you can't times it by 6, because then you get a lot more.
No. You don't need 6. You need 2. How do you get this carbon to be 2?
We just times it by 2?
Just times it by 2. Now look, ready? Now see how this works. You need 6, right? Because over here you need 6. And from this side you have 2 times 2, so there's your 4. And this now is 2 times 1, so that's plus 2. 4 plus 2 equals 6, right? So the carbon is good. Now you have 6. Now, we can do the same thing with our oxygen. How many do we have now? From here, we had 2 times what?
Okay, so we have 6 altogether then.
Yes, but you're jumping ahead. 2 times 1, so that's 2, plus 2 times 2, which is?
4.
That is our 6.
Okay.
That's it.
Okay, now it's done. So it's 1, 2, 2.
1, 2, 2. Yeah. Now look, Emily, when you're doing your balancing, it is a puzzle. So make it a game, but make sure that when you come to the place where you have stuff like this, where there's ingredients in 2 different places, once you get one set the way you like it, like this, remember we had to fix it this way to get the hydrogen right. Try not to change that number. Do this, set it up like this, and you'll be able to figure out how much you only need this to be. Because you didn't need this to be 6, right?
Yeah.
Because this one already was giving some.
Okay.
So try that when you do your balancing from now on and see if it'll help you.
Okay.
All right, so now you're going to do the stoichiometry, and I'm going to just listen to you set up the problem now that you have a balanced chemical equation. And this is going to be a gram-to-gram conversion, just like what we just got done doing.
All right. So they give us. You want me to talk you through it again?
Yep, talk me through it. Yep.
Okay, so we have 750 grams. No.
Don't worry, I'm having one of those mornings too.
All right. We're gonna put 1 mole of, let's see, 1 mole of C2H5OH. Is that right?
Talk me through it.
Okay, so which I always get confused with this. So they want
you to find C2H5OH. They want you to find grams of that.
Okay.
They gave you, when they said, what is the mass of C2H5OH? That's telling you what you're looking for. Mass and this thing, C2H5OH. Produced from, and notice how you're given what you start with, 750 grams C6H12O6. So that's what you're starting with. It's kind of backwards, right? They're telling you what you're looking for first and then what you started with second.
Okay. 6. So that will have 1 mole of that on the bottom.
Are you able to cancel then?
1 mole of that on the top.
Good. Okay.
And we're going to find the grams of that, or the mass of that, and put that in grams on the bottom.
Good. And now, how many moles is this?
Just 1.
Good. All right, so now we're going to try to find carbon, oxygen, and hydrogen, right?
Mm-hmm.
How many carbons do you have?
6.
How many hydrogen?
12. Oh my word.
Good. And how many oxygens?
6.
Good. So that we're going a little faster, carbon is 12.01.
Mm-hmm.
Hydrogen is 1.01.
Mm-hmm.
And oxygen is 16.
Okay.
All right, what do you get?
And I'll forget.
Oh, sorry.
Sorry. Oops. Pressing all the wrong buttons today. I'm doing chemistry. No, not my test.
Oh, you're doing it.
Mm-hmm.
Hi.
She says hi. I'll make sure of that.
How's your dad, by the way?
He's doing good.
Is he still at the hospital or is he home?
He's here. He keeps running around now. He doesn't know when.
Did you say he keeps running around?
Yeah, he doesn't know when to take a break. Which is
You guys need to strap him into his bed so he can rest.
my dad is not that type of a guy for some reason, which is a good thing. He likes to work, but it's a bad thing.
It's a good thing and a bad thing. You're right.
Yeah, so we're all freaking out. Dad, stop!
Take it easy for a minute.
I know. So I got 180.18 grams.
Yes, ma'am. That is correct.
See.
Okay. So now that we have grams to moles, what's next?
6. This is a very long problem. Then we're going to put the coefficients on top. So the coefficient of C6H12O6, that needs to cancel, so we're going to put that on the bottom.
Good.
So that is, let me see, C6, that's 1.
Good.
1 more. C6H12. And then the other thing, C2H5OH, that is 2.
Good. Don't forget to label it completely. It's 1 mole C6H12O6 on the bottom and 2 moles C2H5OH on the top.
Mm-hmm.
But you're correct. That's perfect.
Okay.
All right. So now what?
Then we're going to find the grams of C2H5OH, and we're going to put that right next to it.
Okay, good. So carbon, how many do we have?
One more. Sorry. Carbon, we have 2.
Good. How many hydrogen?
5.
Total?
Oh, 6.
Good. And how many oxygen?
Just 1.
All right, so carbon was 12.01 again.
Mm-hmm.
Hydrogen was 1.01, and oxygen is 16.
Wait. All right, 46.08.
Good. All right, so where does that go, top or bottom?
So it can cancel out, or not cancel out. That's the point. 46.08.
Is that with grams or with moles?
Grams.
Good. And does grams go on the top or the bottom?
The top.
Good.
And then we have 1 mole on the bottom.
Good. So you, since I can't see your paper, the way that you said it, it should look exactly like this, yes?
Yes. Yes, it does.
Good. All right, so now just multiply and divide.
$38, 3, 4, 6, 1, 6, 3. You guys on?
Say that again. Why don't you type it? Because it's harder for me to visualize numbers. So type what's in your calculator really quick.
Okay. Is something wrong?
Well, I don't know if they made the mistake because sometimes they use different molar masses than we use. And so sometimes it's just a little off. It's just a hair because they rounded up. And the way your number is written, it wouldn't round up. So let me just make sure because I'll type it in with the molar masses that we have. And it might just be that. Okay, so I get the same number you got. So it's just that they didn't use the same number of when they did their molar masses, they probably used more than just 2 digits. And so that's why their number's just a little bit different than ours. So this is fine. How many significant figures do you need in your final answer?
Just 3 since there was 3 in the first one, I'm assuming. Because we have 750.
All right, look at 750. How many of those numbers are significant?
There is no decimal, so just 2.
There you go. There's no decimal, so there's only 2 because that 0, it's not in an Oreo, so it's not significant that way, and it's not got a decimal. So that 0 does not get to be significant. So when we round this, we need to have only 2 significant figures. So
38. So just 38?
okay. You can't change the place value with this since it's 383. If you just say 38, you've just, like if I owed you $383, we were going to round down, and I just said, okay, here's $38. Would you be happy?
No, I would not be happy with that.
You would not be happy with that. So keep the same value without adding significance. What numbers don't have significance?
The numbers after the decimal?
Which number 0 through 9 wouldn't count? Same reason why 750 only has 2 sig figs.
I'm slightly confused.
All right.
The chart seems like a lot more than slightly.
Look at that number. What's different between this and this?
There's a 0 there.
Okay, now the 0 is not adding significance, is it? Does it get to count right now?
Yes.
380. Do we count a 0 that doesn't have a decimal and that's not sandwiched between 2 non-zeros?
No.
We do not count it. That's why we didn't count it in the 750, remember? So that 0 is not significant. It doesn't actually add significance. Does it hold a place value?
Yes, it does.
Yes, it does. It's in the ones place, right? So now this number is read as 380, whereas the second number is only read as 38.
Okay.
The difference is, and I think that this is where you're having the problem, significance is not based on place value, right? It's based on the 3 rules that we had when we learned in chapter 2. Do you remember those 3 rules?
If it's not an Oreo, it doesn't matter. And after the decimal, they all count, right? Or no?
Okay. So not quite. So let me refresh your memory. I'll write them down. You write them down as well. All right. So the first rule is all non. And I'm going to use SF as sig figs, okay, or significant. So that means literally 1, 2, 3, 4, 5, 6, 7, 8, and 9. All of these numbers are significant
Mm-hmm.
because they're not 0.
Mm-hmm.
Rule number 2. Zeros that are between non-zeros are significant figures. That's why we say Oreos. So like this, 6, 0, 0, those don't get to count. 6, 0, 2,
Yeah.
0 gets to count because it's between two non-zeros.
Mm-hmm.
Make sense?
Yes.
Rule number 3. If there is a decimal, sorry, I can't type right now.
Mm-hmm.
So the first thing is, if there is a decimal, find the first non-zero.
Mm-hmm.
All numbers after that number. Okay, so let's say that we have 3.00 like that.
Mm-hmm.
Where is the first non-zero reading from left to right, just like we read a book?
3, that's it.
3. That number, everything after it gets to be significant. How
Okay.
many are significant?
3.
All 3. Good. Here's the first non-zero.
44.
The 4, right? So that means you start at the 4, and every number after the 4 is significant. So there's how many?
Just 2.
Just 2. How about with this one?
I have to count now. 1, 2, 3, 4, 5, 6.
Yes, I actually had to count 2. So you started at the 5, and every other 0 got to count because it's after the first non-zero. So it doesn't matter where the decimal is necessarily, right?
Mhm.
It's just that you find the first non-zero and everything after that is significant.
Okay.
The first non-zero could be to the left or the right of the decimal. All right, does that help brush that up?
Yes, it does. I remember that now.
Good. Okay, so I'm officially feeling comfortable with catching you up. I think that we are all good. Do you have any questions before I let you go?
No, I think I got it. Thank you very, very much. I appreciate it.
No problem. And I hope you have a good rainy Saturday. And let your dad know that I am praying for him. And I will talk to you later.
All right. Thank you very much. I'll see you later. Bye.
Bye.